Yeah, thank you all for joining our talk today. We'll be telling you about how we can harness In-toto Attestations for security and compliance with next generation policies. I'm Marcela. This is Trishank. So let's get started. I imagine a lot of people here are actually familiar with the In-toto Attestation Framework, but before that, there was actually a version 1 of the spec that the Attestation Framework is based on, and so we're essentially going to give kind of a historical view of where attestations came from and where we want to go. So the original In-toto spec had so-called links and layouts. What are those? Well, the end goal of In-toto has always been to provide end-to-end supply chain authenticity and integrity. And so in V1, a supply chain owner, I'll say, would define a so-called layout where the expected steps of a supply chain and their sequence would be defined. And then later on, when the supply chain or these individual steps are being executed, sort of the expected actors for each of those steps, the authorized actors, would generate evidence and so-called links that describes the step. And then at the end, any user in the system, any actor, can essentially validate that the kind of final artifact matches the expectation and that the supply chain, the sequence of steps, match the expectation using a so-called inspection. And so to dive a little bit deeper into what a link looks like, the two pieces we want to highlight here is that links very explicitly describe the expected inputs and outputs of a supply chain step. In the actual metadata format, those are called materials and products. And you can see here in a link, you would also collect some information about the command that was run in a step, outputs like standard out and environment variables, and of course the signature. A layout, on the other hand, as I sort of alluded to before, connects the different steps together by defining them as a list of operations that need to happen in that particular sequence, and then a number of inspections that need to be run on the final artifact at the end. And I'm also highlighting here that the expected materials and expected products for each step need to be sort of predefined and known so that the actual steps and proper ordering can be validated. So here is, at this point, we're talking about In-toto V2, where we have attestations and policies. And so why, right? We wanted to address some common problems with links to begin with. Links were considered relatively rigid because they always expected a command to be run as part of a step, even though things like CI workflows may not necessarily do that. They're a little more complex, right? And similarly, not every step in a supply chain necessarily produces a new artifact. And so things like code reviews and vulnerability scans don't transform artifacts, they just sort of perform some sort of analysis, right? And then the other piece that attestations were trying to address is just going beyond the initial sort of link description and to allow anyone to define their own, maybe even proprietary data formats that describe the information that they want to capture at each step, and possibly even reuse existing data formats like SBOM formats. And so this is actually the attestation framework that we all know and love. It consists of essentially 3 main layers. So if you start at the outermost layer, that's the envelope layer. I assume folks here have heard of DISI, perhaps. And that is what contains the signature on the payload. And the payload is what actually contains the metadata captured throughout the supply chain. The statement then has an additional layer, which is the predicate, and that is the specific how should I say, like metadata that is actually collected at a particular step. And so here the example we're giving is an SPDX SBOM that you could put inside of one of these in-toto statements. And then this SBOM, the statement, has a subject field which describes the artifact that, for example, this SBOM applies to. Here, right, our artifact is a container. So going from links to attestations, we've essentially ended up with different predicates for different types of data, and links, the original links, have just become another predicate type. We have more than 10 predicates, and the number keeps growing. And so there's a bunch of different ones that I'm not going to go into, but SLSA provenance, for example, is like a very well-known in-toto predicate at this point.
Thank you. Okay, so as they say, more attestations, more problems. Why? We didn't mean to, so it kind of grew organically. It's a good problem, don't worry, there's a happy ending to the story. So with this added power and flexibility of attestations, now it's not obvious. With links, you kind of knew exactly what the inputs and outputs were, right? Not so with predicate types. What are subjects now? Are they inputs or outputs, or both, maybe? Okay, and then another thing is, attestations let you talk about facts about the world, so to speak, claims. Not necessarily just artifacts, but properties about those artifacts. So how do you check them now? Okay, so why not just reuse layouts? Marcela did a nice job of explaining what layouts look like. You can use it to stitch together links, right, between different steps. Okay, so one obvious problem is that layouts work with links, not attestations. So layouts are simply not aware of different predicate types. And they're not, certainly because of that, they're not aware of what are inputs and outputs. So layouts wouldn't know how to check them necessarily. But we wanted to go further than that. How can we allow you to reuse your own favorite policy language or engine or tooling or framework? There's a whole bunch of different choices you could make here. And we didn't want to pigeonhole people into any one of them. More importantly, how can I reuse verification? Great, so I've got this policy, I've got this attestations, I've got verification. Now what? Okay, so the big picture, this is what we ended up with, and we love your feedback here. I'll explain them step by step, pun intended. Okay, the first aside, someone mentioned here earlier that supply chains, although we'll be looking at a linear example because that's what easiest to draw pictures about, just keep in mind the supply chains. In-toto is rich enough to model supply chains as directed acyclic graphs, which is what they are in general, right? So although we show you linear examples, just keep that in mind, that we can model DAGs. Okay, so the first simple but powerful idea is this idea of what we call input-output selectors per step. So you can see here in the picture, we have two different steps here. We've got two different attestations here. And here's a nice little trick. We can say that the subject, which is what the attestation framework lets you do, the subject of the first step happens to be the output in this case. In the second case, it's the input. So note how we don't need to require people to make backwards incompatible changes with the attestations. Keep producing them as they are. We've shifted the complexity to the policies to let you select, what are inputs and outputs. Okay, so the next simple idea, add the predicate type to the step. So you know what, you can do nice little things like a policy engine could do type checking here if it wanted to, because now you specified the type. And what can you do with that? Once you've checked the type, now you can do powerful things like checking logical expressions you might want to test against the predicate. So you could do simple Boolean expressions, right? Or you could even go as far as propositional logic. You can check, does some attribute here meet what I'm looking for? Do all of them meet this criteria that I'm looking for? And you can model this as a nice little Boolean function too, so that you can pass it off to your favorite policy engine and get back the answer. So this lets you use any engine that you like, and you're not bound to one thing or another. Okay, and then last but not least, another powerful idea is that our friends in SLSA have this very nice attestation called the verification summary attestation, which you might have heard about. We took that idea and we generalized it. What do we mean by that? Verification summary attestation tells you whether something met SLSA policy, whether it's Bill L2 compliant, let's say. We wanted to take it and make it so that it's generic, generalized in the sense that you could talk about any policy you care about, not just something specific to SLSA. So here you can see at the end, really think about this generalized, we want this verification. Remember, talking about this idea of reusing verification. So at the end, potentially expensive verification, you get this generalized VSA that you can reuse elsewhere. You could choose to trust it, or you could do reproducible verification. Heard of reproducible bills? With reproducible verification, you can take the policy in attestation and double check it yourself. Do you get the same results? Okay, so case study. Let's see how we took, this is not merely theoretical, we took all of these ideas that we were playing with in-toto policies and we applied them at Datadog. Okay, so here's the big picture architecture. Let's walk through them step by step again. So the first thing that we came up with is this idea of an attestation library that, so producers only want, they care about a specific predicate type. Say they're producing a bill provenance or a walnut scan. They're not going to care about things like signing and how to store those attestations. That's what this library is there for, is to do that heavy lifting for them so that they don't care about those relatively boring parts. They only care about, I want to produce this attestation, here it is, figure out how to sign and store it. So you can choose any key management backend system that you want to use here. Okay, so now we have a second problem. Great, now we've got all these attestations. Where do we keep them? So there's this nice little service in between. We found you could use either SQL or NoSQL. There's different trade-offs. Happy to talk about them offline. Great. And then another problem we ran into is sometimes, so you're given an artifact to evaluate. You've got a policy. What's the attestations I'm supposed to look at as supporting evidence? Sometimes you know them ahead of time. Sometimes you don't. So think about it. Say one of these attestations, walnut scan. Today, your image may not be vulnerable. Tomorrow, it may be. So this idea of being able to dynamically compile these attestation bundles can be useful. So that's something that we also designed. The policy repository is the system that tells you what are the latest known good policies, so you can distribute them securely. You can revoke trust in them later. Yesterday, this policy was good. Today, no more. Maybe we added one more requirement. And we use something, a sister project called Tough, to securely distribute it. The high-level problem is this. How do I know which artifacts, which version of a policy do I use to evaluate which artifacts? Can talk about that offline, too. And then the second last piece of the puzzle is something called a policy evaluator. This is the thing that finally takes all of those latest known good policies. It talks to the bundle compiler and says, OK, look, I've got this artifact to evaluate. Someone gave this to me. This is the policy that I want to evaluate against. Could be one or more, actually. And talks to the bundle compiler to get the latest attestation bundles. And off it goes. And how does it know when to trigger? Well, there's this classic data pattern called the change data capture, where we're listening to certain events, certain attestations being produced. Maybe someone pushed a new image to the registry, for example. And off you go. You can evaluate every single image that ever got pushed. Okay, and the last piece of the puzzle, something we came up with, I'll talk about in just a minute, is the Datadog ticket. Just remember the generalized VSA that I talked about earlier? Well, we took that, we generalized it even more. I'll explain what that means. Okay, so here's a nice little example that also talks about a few sister projects. One is okay, let me explain the policy. So here's an end-to-end policy that governs container images, your supply chain security for container images, all the way from source to the moment it's pushed to the registry. So the first attestation, you could use something like GitTough to produce a SLSA v1.2 source VSA to say whether this source code is authorized. That could mean any number of things. It's up to you. Again, happy to talk offline. Second attestation you can require is, was this produced in my CI system, though? And using the same commit tree, for example. And what was the resulting image? What dependencies did I use? All this kind of good stuff. And last but not least, you want to check that since you pushed that image from CI to the registry, it hasn't been tampered with. So end-to-end supply chain security. Okay, and then here's what our Datadog ticket, as promised, does look like. You can see that we can evaluate an artifact. When we give you a ticket, it can expire. Turns out this is useful in a number of places. And it can meet one or more policies. You can talk about which policies it succeeded and which policies failed and why. And everything comes with an evidence. So you can reproduce this yourself if you wanted to. Off to Marcela.
Thanks. So to wrap up, right, a lot of the work that we're talking about is already underway. In-toto the In-toto spec already has some enhancements that are in draft to cover some of the changes that we presented. But what we really want you to take away from this talk is that the In-toto v2 policies specification is trying to address key challenges that supply chain policy writers face today by offering a clear separation between verification of the supply chain DAG and the per-step security attributes that you capture at each individual step. We also think that this new or updated policy framework provides the ability to abstract away upstream supply chain steps, and that actually provides a better balance, we think, between confidentiality and transparency, where oftentimes enterprises don't actually want to reveal every single detail about their pipelines and supply chains, and so something like a generalized VSA or ticket at Datadog can do that. And finally, this is coming soon, but we really hope that everyone here will provide us with their input on the draft specification for the policies. There have been a lot of people, more than we can name right now, that have been involved in this work, but we thank all of them. This really wouldn't have been possible without everyone here. So yeah, please reach out to us via email or on Slack, where we commonly post. And right now, Trishank and I are the shepherds for this, but this is absolutely a community-driven effort. So yeah, we'd like to hear from you. Thank you.
All right, we got some time for questions. Everyone's tired, everyone's done. We got one more session, then we got a break. We got some snacks. I see a hand, thank you. Get my steps in, warm up. It's cold. Where was the hand? I saw a hand, there it is.
What are your thoughts about removing information from this verification attestation and instead generating provenance for the attestation to record some of this data?
You want to take that first?
Yeah, thanks for the question. Yes, what you're essentially asking, currently the VSA has a lot of informational fields that may or may not be actually used in verification, right? What are our thoughts? I'm not exactly sure, right? Clearly I think the SLSA folks sort of decided to put information about policies that were verified and input attestations and those types of things into that format to be able to, I guess, trace everything back and review everything if there was a need for that. But on the other hand, there's value in being able to say, hey, this is actually kind of an endorsement of my upstream, essentially. So, and in that case, you don't need to have all of that information. And so I absolutely think there's room for both. Maybe I'm being a diplomat here, but either way, I think this is something that is open and certainly something that we ought to talk about more, because I know from the SLSA side, there are also a lot of discussions about this. Yeah, please.
Thanks. So let's talk offline, but think of the ticket as a shortcut. And you don't need to reveal all the details right away. You can even point to like content addressable style hashes of these attestations. You don't have to reveal all your cards right away. Push comes to shove though, you can. So I think that's one path forward.